Okay, this is the last lesson we have now. So this time we're doing probability, but it's dependent. So the probability is going to change. We're not each poll is not independent. It's going to be where the previous poll is going to change the odds for the next poll, and so on and so forth. And we've kind of already did this with the previous chapter with combinations, but we'll go from there. So big thing here, the formula is right here. You kind of ignore this part here, so I put it underneath. Okay. So essentially, the combination you want, using things of interest you want, times the rest of it. Okay? And then we have an expected value for this here, too. It's RA times N. Sample size times number of items of interest divided by the total options. Okay, so with that in mind, pull this over. Pull that. All right, here we go. So as jury is put together, jury is being put together for Mr. O's trial. There are 8 students and 10 adults in the pool to pick from. The jury consists of 6 people. What's the probability that 4 students will be on the jury? All right. So the number of options N is going to be 18. 18 altogether. Okay. Items of interest in this case are A. Our items of interest that we're concerned with are students. So that's A. X, how many students do we want? Well, we want 4 students. And then our sample size, R, is a 6-person jury, so it's 6. Right? So we follow that's the probability of 4 students, is ACX times N minus A CR minus X divided by NCR. So the way I look at it, okay, so we have 8 students. We want 4 of them. Then of the rest, we have 10 adults, and we need 2 of those. Now, realistically, that is 18 minus 8 gives us 10, and 6 minus 4 gives us 2. Divided by all my options, so it's 18C6. Okay? So if I run that in the calculator, divided by 18C6 is going to equal about a 17% chance. Okay? Now, if we were to try to find what's the expected number of students, the expected number of students, that's going to be RA times N. So RA divided by N, sorry. So R is going to be 6 times our A is 8. Okay, R is our sample size, so we have a 6-person jury, 8 people of interest, and N is our total options of 18. All right, so that's going to be 6 times 8 divided by 18. So on average, there's approximately 2.7 students on the jury. Okay? I can't do this with my keyboard up. Bring this with me, so I always have my formula beside me. All right. So iPhones are purchased in cases of 10. In case of 10, from the case, 4 iPhones are inspected. If one or more of the sampled phones are defective, the case is rejected. Okay, so you buy a box of 10, they test 4. If there's one defective, they get rid of it. What's the probability the box will be rejected if the box contains 3 defective iPhones? All right. So if we look here, Our N, all options, is going to be 10. Number of items of interest. Okay, we're looking for defective ones. There's 3 defective iPhones in there. How many do I want? Well, realistically, I want 4 of them. I want 1. I also want 2, because we also get 3. That's all the possible ones we can get, right? Because we could select 4 iPhones out and get 1 that's defective, 2 that's defective, or 3 that's defective. And those would all result in the box being rejected. Okay? And then our sample size is 4. Right? So our formula for the first one is going to be 3C1 times 7C3 divided by 10C4. Okay? So there's 3 defective. We want to get 1 of them, times the 7 that aren't defective. We want to get 3 of those. Now for the second one, it would be 3C2 times 7C2 divided by 10C4. And for a third one, it would be 3C3 times 7C1 divided by 10C4. Okay? So we can run all those numbers. So 3C1 times 7C3 divided by 10C4. So the probability of getting 1 being defective out of the sample is 0.5. So 50% chance. 3C2 times 7C2 divided by 10C4. Get out of here. Is 30%. And the last one, the probability of getting 3 defective would be 1 in 30, which is 0.3. So I add all those up. It's going to give me 0.83% chance, or an 83% chance that box is going to be rejected. Okay. Now, what's the expected number? Our expected number is RA divided by N. So R is 4 times A is 3 divided by 10. So 0.7 is our expected number of defective iPhones. Oh no, sorry, my bad. I added those numbers together. That's going to be 1.2. So on average, if we were to select out of a box with 3 defective, and I'm selecting 4, we're going to average get 1.7 defective iPhones. All right. Let me do this. Move that over there. Paste that there. Oh, not there. Paste that there. All right. Here we go. So as I say, always take a minute. You can always pause the video, because I have a tendency to go a little bit quicker, to see if you can get the equation right. So a random sample of 50 students. So my N is going to be 50. Selected from that's not my N, that's my sample size. That's my R. From a population of 1,000, that's my N. In the school, 225 students have been bitten by zombies. Well, they're my people of interest. I'm interested in that 225. What's the probability that you will select less than 4 who have become a zombie if you randomly select 5? So my R, so my X here, I want less than 4. So it's going to be 1, 2, and 3. Those are going to be my 3 ones I'm going to do. Okay. So I'm going to go 2, 2, 5, choose 1 to start. And now there's going to be how many people left? 775, choose 4. Divided by 1,000, choose 5. Okay? So 2, 2, 5, choose 1. Oops. Choose 1 times 775, choose 4. Divided by 1,000, choose 5. So it's a 41% chance I get one person. Okay? Then my 2 will be 2, 2, 5, choose 2, times 775, choose 3, divided by 1,000, choose 5. Okay? 2, 2, 5. Oh. That's about 24%. And then we can do the last one as well. 2, 2, 5, choose 3 this time. Times 775, choose 2, divided by 1,000, choose 5. Oh, crud. I'm going to pull something weird up here. There. And about a 7% chance. So add all those 3 up. 48, 68, 72% chance. We'll find a zombie if we select 225 people. Okay? Do 2 more. We'll do this easy one, and we'll do a harder one. So in a class of 30 students, 5 are spies sent from the office. What is the probability if I select 7 students, 2 will be spies? All right, so my full sample is 30. My items of interest, what's my... Oh, I guess I'm going to work sideways then. My item of interest is going to be 5. That's my spies around. My sample size is going to be 7. And the number that I want is 2. Okay? So I'm going to 5 choose 2 first. There's 5 spies. I want 2 of them. Then there's 30 students. 5 are spies. That's going to mean 25 are left over. And I'm going to choose... I'm picking how many? If I select 7 students, it's going to be 5 left over there. Divided by 30, C7. So 5 choose 2 times 25 choose 5 equals divided by 30 choose 7. So the probability of getting exactly 2 and my sample is about 26%. Now we can even extend this a little bit. I'm going to put my question right here so we can keep that there. Let's say we have candy. There's 5 fun dips, 6 nerds, 3 Kit Kat, and 5 what? Let's go 6 Jolly Ranchers. Okay? And I hate Jolly Ranchers for some reason. Not that good. What's the probability I get, if I select 5, I'm going to select 5. I get 2 nerds, 1 Kit Kat, and 2 Fun Dip. Actually, I'm just going to go with that. What's probably I get 2 nerds and 1 Kit Kat. Right? So this I want to kind of massage a little because we have multiple things of interest. Right? So all options, we have, I think I added up to 20. Good. Our numbers of interest, we have nerd numbers of interest, which is 6. And we have Kit Kat numbers of interest, which is 3. How many do we want? We want 2 nerds, and we want 1 Kit Kat. And my sample size is going to be 5. So we're going to kind of break this down. Let's do nerds first. So it's going to be 6C3 times, now the Kit Kat's going to be 2C1. Now we still have, how many more candies to get? We still have 2 more candies to get. But we don't care if they're Fun Dip or Jolly Ranchers, so it's going to be 11C2 divided by everything together, which is going to be 20C5. So this are nerds. This is our Fun Dip. Oh, sorry, Fun Dip. Did I get my numbers right? Oh, sorry, that is our Kit Kat. And this here is Fun Dip and Jolly Ranchers, because we don't really care what number we get from there. Okay? And then we go 6C3 times 2C1 times 11C2. That's our top, and we're going to divide it by 20C5. And we get a number we shouldn't get. Let's try that over again. 6C3 times 2C1 times 11C2. Oh, we picked more than 5 things. That should be, that's supposed to be 2 nerds. Oh, that's okay. That should be 2, which makes that 2. 2 nerds, 2 nerds. Now it's 2, 3, 4, 5. Okay, there we go. Let's try this again. 6C2 times 2C1 times 11. And that should be not 11. Yep. Divided by 20C5. Oh, I made another error. That should be 3. Shoot. Okay, last time's a charm. 6C2 times 3C1 times 11C2 divided by 20C5. There we go. So we have a 16% chance of that happening. Okay. So hopefully that's the last video I have for that. Have a great day.